A few years ago, in the FT 6.0 forum, fuel pump issues were showing up. So, Jack created a poll to document when they failed, to find if there was a pattern. The poll showed a 25% failure rate, usually below 200,000 miles. Here are the typical steps given in the forums to solve the problem when someone has a fuel supply issue. Initially, you need to listen if you can hear the pump running. If it's not running, the inertia switch in the passenger footwell needs to be checked. First, that it didn't trip, and then if the switch has voltage within the first 20 seconds of key on. No voltage would mean the fuse or the embedded relay in the fuse panel is blown. The fuse is easy. The relay is not. If that is fine, running or not, check the voltage at the pump through the back of the connector while it's attached to the pump. You want to test under load in case there is a resistance problem. Under load, the voltage will drop if there is resistance somewhere in the circuit, and the pump's output would be diminished. If you test voltage without a load, you'll never see the drop. Then do the physical checks for O-rings that could allow air to enter. Most of us don't have the parts to assemble the equipment that mimics what Ford techs have. Checking the vacuum on the supply side and pressure on the delivery side. Without those tools, the only way to rule out a tank or supply line problem is to use an alternate fuel source. Using a fuel can and connecting hoses to confirm it's not a supply side issue. 2 forum members had replaced their HFCMs, which solved their issues. So, Jack asked if they would send him their failed units to do a forensic teardown and determine what went wrong. He was in the middle of other things, so Jack put them on the shelf and forgot about them until recently. The first one is Robert's. Here's the abridged rundown. 160,000 miles. No fuel in secondary filter. The pump runs. Voltage at the pump is good. Recently changed the filters, but changed again just to be sure. A remote fuel source was tried without any change. He replaced the HFCM, and everything ran fine. Before sending it to Jack, he washed the water collection area and pulled the filter. The filter would have caused concern when shipping due to the diesel smell. The majority of this video is step-by-step forensics, which takes time and is tedious. For those who did not care to follow the steps, don't want to be Jack, here are the shortcuts to the issues found. So, let's start the forensics. The first check is the cap O-ring, and it's in good condition. A nicked O-ring can cause a failure to pump by letting air pass through. The filter area has some debris, which likely broke loose from the water drain area during shipping. Brake cleaner was sprayed into the water collection chamber, making it more pliable. This is the fuel tank anti-drain back valve, and it's okay. This pump's housing has corrosion. It could be evidence of water or organics in the fuel, which can be bacteria or algae. Being in Miami, hot, humid, with occasional hurricanes. Maybe some of the loose debris landed here, corroding after years on the shelf. This is an early HFCM, so it still had the fuel heater. Ford deleted the fuel heaters mid-year 2005. Since the heaters turn on at temperatures under 50 degrees Fahrenheit, if this truck had always been in South Florida, it would be unusual to turn on. But that's not how this looks. Maybe the truck was from the north. The heater did an excellent job of cooking the fuel into a mess, which is why they were deleted. You can't reach this area from the drain hole, you must remove the cover. It's interesting how the debris condensed on the cooler thermostat after warming on the heating plate. How does this happen? Here are some indications. Not going to review all this, but you can pause the video to read it. It has more detail for reasons for the wax buildup. The output chamber to the secondary filter has no issues, so the primary filter did its job. And the return chamber from the secondary filter is clear. Removing the replaceable pump when it's on a bench is easy. The thermostat control valve that recirculates cold fuel is removed to look around. At this point, the heater assembly is washed to view it better. This mass is potting compound. These chambers cleaned up well, but show some pitting. The collar on the nose of the pump assembly retracts when the filter is installed to open the pump's inlet ports. If for some reason a filter does not push it open against the spring, this would be an issue, possibly with some aftermarket filters. Robert said he could hear the pump run, so let's check that out directly off a battery. There doesn't appear to be anything unusual here. The copper leads look good. Actually, very good compared to others examined. Being destructive seems to be the only way to remove these connections. And there are no issues here. This shell was cut to take the pump apart for forensic analysis. You can never go back and reuse these when you do this. The carbon brushes are in good condition. Really, really good condition. Pulling off the brush holder, we can see the commutator. It's in good condition too. This is not a 160,000-mile pump. For reference, this is the 187,000-mile fuel pump motor that Pete, 87 Crew Dooley, provided long ago. This was used in the earlier video about how the HFCM works. The prior owner of the truck probably had fuel delivery issues and replaced only the pump. With the collar removed, we can see the intake ports easily. If this collar does not fully retract, the delivery to the fuel pump will be hindered, and the pump will not be able to deliver enough volume to maintain fuel pressure at full throttle. The roller pump's intake port and the 100 psi pressure relief valve. No issues in this area. Some debris has collected on the backside of the nose. But there is nothing on the internal screen. There is always a chance small material can make it through the air bleed venting hole in the filter body, or some may fall onto the pump housing during a filter change and be trapped inside the new filter. The screen will capture the larger material. The smaller ones will go through the pump but are blocked by the 4-micron secondary filter, protecting the injectors. Now disassembling the roller pump. There are no issues with the rollers, no excessive wear on the side plates. This is a newer pump. No issues with the 100 psi pressure relief valve, which opens if the fuel is blocked. This may be some plastic from pulling this apart. The motor's drive gear is in good shape. We know the motor was operational. But Jack said he'd do a forensic assessment, so he is doing the standard tests you would do to check a DC motor. One bad segment could lower the speed and power. There is always some variation in measuring resistance this low with a meter like this. Relatively equal resistance 180 degrees across the commutator segments. No opens or broken windings. Relatively equal resistance between the commutator segments. And no shorts from the commutator to the armature. Jack could not find anything to explain why this was not pumping. Or maybe there was. Let's go back to removing the manifold cover. Look at all the material in the back of the heating chamber. This area is the link between the fuel tank and the primary filter. A lot of material has been attached to the thermostat, and some of it was knocked off either during shipping or when this was taken apart, as these areas don't appear the same. The TSB to delete the heater has the words "may require replacement." Some people never deleted the heaters. These two HFCMs are good examples. If this vehicle spent most of its life in Miami, chances are the temperature would rarely go below the activating 50 degrees. The operating range is 50 degrees on and 80 degrees off. The meter's clamps are placed across the thermostat leads, so the temperature range can be demonstrated. The deposits are created on the hot plate but condense on the thermostat. And they would probably be a good insulator. This would have caused the heater to stay on longer than it was designed for, creating more of a mess, filling this cavity up. After the wash, you could still scrape a layer of the collected material at the anti-drain back valve port, the gateway to the filter area. This area is under vacuum, not high pressure. The valve has spring tension, enough to keep it closed so the fuel tank does not drain out when you change the primary fuel filter. And it opens to the side. If too much debris collects in this area, it could restrict the fuel flowing from the tank to the pump. The molded wax's flat area corresponds with the chamber's flat surface. This is where the valve is located. This area of the wax buildup is broken. There was wax in the port that was scraped away. And all of the material at the back of the chamber most likely was in front of the port to the valve, which is how fuel gets to the filter and pump. And with the port blocked, the atmospheric pressure could not open the valve when the filter chamber was under vacuum, the pump trying to pump fuel. This system is designed as a constant volume delivery out of the HFCM. Pressure is maintained by the pressure regulator in the secondary filter, and the injector flow is bled off this loop. But just like our alternators, the pressure drops if there is not enough flow during demand. The voltage drops if there is not enough current during demand. And with a reduced flow, the overall fuel pressure at the fuel injectors could drop more than the 52 to 55 psi level we can see under high load conditions. And possibly all the time if it's bad enough. Yet, we often think that's only an issue with the fuel pressure regulator. It can be a supply-side problem. And it looks like the previous owner replaced the pump only. However, installing the new pump may have briefly cleared the pathway by breaking off materials. It was just a matter of time. Robert's time. Let's add it to the checklist. HFCM2. The second HFCM failure was similar, a running pump motor with no fuel delivery. This truck had over 100,000 miles, and the HFCM also had a fuel heater. Before Dave took possession of the truck, it sat for 3 years, although it was driven around occasionally. His earlier posts indicate he did have a primary filter issue after acquiring it. Jack will go through the same forensic steps. The cap O-ring is in good condition, and the filter chamber is relatively clean. The pump sounds a little different, but it's still in the housing. This cap is a bit different. Looking at the first example, maybe the early factory units didn't have the markings. The HFCM housing shows less debris or corrosion, although it feels gritty. The fuel tank anti-drain back valve is in good condition. When Dave changed this HFCM, he showed a picture with the cover removed. These two chambers have some debris. This truck is in the upper part of Florida and it can get below freezing there. So, it would have heater activity. It could have been washed before, or the heater fuse, or the relay was removed earlier. But still, hot, humid, with occasional hurricanes. There is staining on the chamber walls as though it had debris at some point. But the concern here is the debris in the return chamber from the secondary filter, which may have occurred during the failure of the primary filter. The thermostatic valve holder looks funky. So, let's see how the pump sounds outside of the housing. And compared to the other pumps Jack has. These copper electrical strips are darker and older. As mentioned, the fuel is pumped into this area before heading for the secondary filter. Jack caused these silver flakes when doing some cutting. Here is one of the two ports that pass fuel into the cap area. So, the leads and mounting pads are darker and have more corrosion. More corrosion than Pete's 185,000-mile pump. South Jersey is hot and humid with occasional hurricanes. As mentioned before, the shell has a gritty feel to it, and this area should be the filtered side. A bad attempt to try to see if it will open this way. The brushes and commutator also show more wear than the earlier pump. Probably more like a 100,000-mile pump. And there is debris in the pump itself. Another view of some of it. More debris. And more debris. The pressure relief piston has debris collected on its face. Looking at the inside of the actual pump's shell, next to the relief valve, you can see staining from dirty fuel. And it had to be happening for some time to leave a stain like this. Maybe the high-pressure relief valve was partially open. In that case, not all of the fuel goes to the secondary filter, which may starve the injectors under high demand. So, confirming there is nothing wrong with the fuel pump's electrical motor, because this is a forensic journey. All good. Somewhere along the line, there was excessive debris in this fuel system and a catastrophic failure of the primary filter. But nothing on this list, or the inspection done, shows why this HFCM did not pump fuel. The relief valve was not stuck wide open. And the heating chamber was not clogged. This was when Jack sent Dave a message. There had to be a blockage on the pressure side for the high-pressure blow-off valve to bypass fuel, not filling the secondary filter. There was gritty debris on what should be the clean fuel side and the return from the secondary filter. If you hunt the 6.0-liter forums, you'll find examples of people getting dirty diesel fuel at stations. And with heat and humidity, you can get organic growth, bacteria, and algae. It's not necessarily an indication of poor maintenance. So, going back to the manifold cover. Jack went a little Neanderthal with Dave's heater assembly to get it out of the way for inspection. First, looking at Robert's cover. With the steel drain plug, we can see that almost 2 decades of exposure to water have caused corrosion. This would be the bottom side of the plug when it's installed, exposed to the most amount of water. With Dave's cover, the threads show corrosion. And the drain plug shows much more corrosion from water. With 60,000 fewer miles, it had a more challenging life due to the 3 years of inactivity or something else. Heat, humidity, occasional hurricanes? This is the fuel tank input and output to the secondary filter. The return from the secondary filter and return to the fuel tank. We can see some light coming through. So, all of these are clear. Let's move to Dave's cover. Open, but a little dirty. But now life gets interesting. So, at some point, there was an issue. Dirty fuel, organics from a station, or developed organics in the tank. With Florida hurricanes, like Jack and Pete also get in Jersey, stations can get underwater. But the other problem was the failure of the primary filter, which allowed debris to circulate throughout the fuel system. The return output to the tank may have been the first to block, mimicking a warming loop with cold fuel. As the injectors used fuel, makeup fuel would be sipping from the tank, not a full normal flow. This would not have to be a significant quantity of debris. Or maybe it was. Let's go back to one earlier screenshot. They discuss organics and how biocides can make the issue worse. It's a possibility to what may have occurred, but not a certainty. And it's rarely mentioned in the forums to check these for blockage. But some people do. People will change the filter. God knows how often filters get changed just because the truck doesn't run well, no matter what the reason. They may check under the manifold cover, or buy a new HFCM. These two examples show it's important to occasionally drain and inspect the water chamber. And more so if you have an early truck with the fuel heater, check under the manifold cover. Even if the fuse or relay is removed, that area should be checked. And it's best to install a new manifold cover without the heater. Both of these trucks have been in service for 2 decades. Over 20 years you would expect the steel drain plugs to have eroded. Debris in the inflow heating chamber can slow the fill rate of the HFCM. And the system would be more likely to have a lower fuel pressure when the injector demand is high. Another good suggestion is getting fuel receipts and holding them for some time in case you get a bad tank of fuel. Some of these failures may have been more about blockage than electric pump failure. But it's an old pump, so the HFCM is replaced. And this writer feels bad for wasting 2 pumps in forensics mode rather than mechanic mode. We should check things before destroying or replacing them. That's easy to say here in a garage, not under a truck with the frustration of trying to get it to run. And Jack needs a kick in the tail about holding this inspection off for so long, as possibly the information might have helped Dave. Depending on the second HFCM failure. Dave's replacement Napa HFCM failed in 9 months, although he believes it was due to aftermarket quality. It should have been a Carter reboxed Raycor unit. And afterwards, Dave's tank's foot fell apart. Dave and his father always used fuel additives. This writer is wary of some additives as we've seen many of those same in-tank issues recently. But it's only speculation if additives have anything to do with the failures. If you have debris blocking some ports, it's wise to examine all of the fuel system. Here are some part numbers. When you buy the entire cover, it comes with a new gasket. These 2 kits provide you with a replacement gasket for the manifold cover. The other parts may not be needed. Keith, Ford doctor, discovered this great solution long ago working on the short-lived Ford LCF with the 4.5L Powerstroke. A replacement drain plug that won't rust and is easy to remove. Recently, pricing on the Raycor individual pumps and the Ford HFCM assembly have dramatically gone up, which really makes Jack feel bad about destroying those 2 pumps last summer. Thanks for watching, and please hit the like button if it was worth your time and if you think this video may help others.